Good afternoon, everyone. Today we're going to write the equation of a line in three different ways, namely the line that passes through the points P at 2, -1, and also point Q at -1, 8. So first things first, whenever we see 2 points on a given line, we know we can find the slope. Right, so let's find the slope M, which we know is the difference in Y over the difference in X, right, or rise over our run. And so we can say 8 minus -1, the difference in the Y coordinates, over -1 minus 2, the difference in the x coordinates, and that is 9 over -3, or if you'd rather, simply -3, so that's our slope. And now we have 2 points to choose from. Neither of these are the y-intercept, and so there's no real use to jump into slope-intercept form because that would require some more work. We have 2 points and a slope, so we can use slope-point form using either of the points on the line to write an equation right away, right? Because that's readily available to us. And so let's go ahead and do that. That's readily available to us. Sorry. So in point slope form, I'll use the coordinates of point P for no specific reason rather than point Q. So we have y minus the y coordinate, so it'll be y minus -1 is equal to the slope, -3 times x minus the x coordinate of the point we're using, and minus -1 is the same as adding 1, so we can write this a tiny bit simplified as y plus 1 is equal to -3 bracket x minus 2. Okay, now we can convert that pretty quickly to either form. I'll go to slope intercept next. And then finally, we'll do general. Slope-intercept form, that's the form y is equal to mx plus b. The slope times our variable x plus b intercept y coordinate. So let's go ahead and do that. The slope-intercept form is characterized by having y by itself and having y equals mx plus b. So really the goal in writing in that form is isolating the y, right? We don't have much work to do here. We're just going to subtract 1 from both sides to get rid of the +1 that is currently accompanying the y. And of course, we'll have to multiply through the brackets because there are no brackets in mx plus b. Right, so let's go ahead and do that. So we'll have y plus 1 is equal to, I'll multiply through the brackets, -3x plus 6, right? -3 times -2. And then all we have left to do is subtract 1 from both sides. And we get that y is equal to -3x plus 5. That takes care of slope-intercept form. And finally, I'll write the last one over here, general form. That's of the form ax plus by plus c is equal to 0. So we want everything on one side. We want no fractional coefficients, and we want a positive x term all in one, right? I'll just remind you, ax plus by plus c equals 0, right? So we can move either one into that form. I'll work with the slope-intercept form. So we have an x term on the right side here, it's negative. We know we want it to be positive in the end, necessarily. So since it's negative on this side, let's add 3x on both sides. That will give us a positive term on the other side. So I'll do plus 3x on both sides. And I want to move everything on the same side of the equal sign, right? So since we're moving everything on the left side, let's boot that +5 over as well. Let's get rid of the +5 on the right side. We'll subtract 5 on both sides, right? So we'll have nothing left on the right side, and we'll have 3x, because we always start with the x term. So we'll have 3x plus y, because the y is hanging around there. X, then y, and then the constant term. We have -5, and that's the only constant term at play here. And so 3x plus y minus 5, and now there will be nothing left on the right-hand side, and so we have it equal to 0 as desired by our general form. And there we go. So from 2 points on the line, we got the slope, wrote it in the point slope form from the slope and the coordinates of a point. We could have used the point Q. We would have gotten the exact same equations in the end, and we were able to convert them from one form to another. So I hope this helps. Thanks for watching.